So good morning. We will just wait for your other classmates kasi 14 pa lang kayo and you are 26. So while waiting, kindly unmute muna yung microphone ninyo. Paki-unmute nyo, may naririnig kasi akong ano eh. Okay, so while waiting for your classmate, kindly fill out the form. Nasa chat box natin for your attendance. Okay, I think we can start. Naririnig nyo ba ako? Clear ba yung audio?
Yes, ma'am.
Yes, ma'am.
Okay. I will just share the screen. Okay, so makikita yung screen ko.
Yes, ma'am.
Okay. So, ada makita yon nga problem. Wala.
When ma'am.
Okay. So, last meeting, na-discuss natin yung moment diagram by parts. Okay? We'll now proceed to our next topic. Magsa-start na tayo sa deflection of beams. So, to solve for deflection of beams, merong different method yan. So meron tayong double integration, meron tayong moment area method, meron tayong conjugate beam method, meron din tayong virtual work. Okay? So, unang i-discuss natin yung unang method, which is the double integration method. I think ito yung pinakamadali sa kanilang lahat, yung method na binanggit ko. Ito yung pinakamadali to solve for the slope and deflection of structure. Okay? So, double integration method. So, double integration method involves writing an expression for M over EI. So, yung bending moment natin divided by the flexural rigidity, yung EI. Ito yung flexural rigidity natin, yung EI, in terms of distance. So, in terms of distance along the axis of the beam. Then, i-integrate natin yan to obtain equation for solving the slope and then the deflection of the elastic curve of the beam. Okay? So yung constant integration, this is determined from yung tinatawag nating boundary condition. Okay? Mamaya ipapakita ko sa inyo mamaya yung boundary condition. Okay? So this method proves to be the most convenient for computing slope and deflection of beams, for which yung MEI can be expressed as a single continuous function of x over yung entire length natin sa beam. Okay? So when the application of MEI function, pag yung application ng MEI function is not continuous, yung solution natin magiging complicated. This is because yung discontinuity nung changes ng load at yung flexural rigidity. Okay? So, dito sa double integration method, yung slope natin, yung pagkuha ng slope nung ating beam is equal to the equation nung first integral natin. Pagka nakuha natin yung equation ng moment, i-integrate natin yan. Yung first integral natin, which is equal to dy over dx, yan yung magiging slope or yung tinatawag nating rotation of the elastic curve. Okay? So yung first integral, yun yung slope natin. Pagka in-integrate ulit natin ito, magkakaroon na tayo ng second integration. So ito na yung magiging deflection natin. Yung equation ng second integration natin. Okay? So yung first integral ng moment equation natin, yan yung slope natin, equation for slope, to solve for slope. At yung pangalawang integration natin, pag in-integrate pa natin yan, yung equation natin is used to solve for the deflection. Okay? So, slope is denoted yung theta, slope yan, and then yung delta, yan yung ating deflection. Okay? So, meron tayong boundary conditions for the double integration methods. Okay? So, pagka sinabi mong roller, yung support natin is roller or hinge. Ang slope natin, meron tayong slope. So, meron tayong slope pag roller or hinge. So, pagka ito yung simple beam natin, di ba, pag nag-apply tayo ng load, ang elastic curve yan, magaganyan. Okay? So, ito, hinge, ito, roller. Di ba? So, pagka hinge or roller, meron tayong slope, kasi meron yang rotation, nag-rotate yan. Pero yung deflection natin is 0. Wala tayong deflection dyan. Okay? So nag-rotate lang yung pagkaganyan yung simple beam natin, tapos nag-apply tayo ng load, ang elastic curve yan magaganyan. Okay? Meron tayong rotation, wala tayong deflection. Pag roller or hinge. Okay? So pag fix naman yung support natin, di ba? Pag ganyan yung fix, pag nag-apply tayo ng load, ang elastic curve niyan, gaganyan. Diba? Ganyan yung elastic curve niyan pag fix. So pagka-fix, ang rotation natin, 0. Ang deflection natin, 0. So wala tayong rotation, wala tayong deflection sa fixed support. Okay? So ganyan yung magiging elastic curve niyan pagka fix ito. So pagka may ganyan, fix dito, tapos hinge dito, walang rotation sa fix, walang deflection. Pag ganyan yung elastic curve natin, so mag-straight muna bago bababa kasi wala nga tayong deflection, wala tayong rotation. Pero dito sa may hinge, meron tayong rotation, wala tayong deflection, so 0 pa rin yan. So ganyan yung magiging elastic curve natin. Okay? And pagka free end, di ba? Pagka free end, for example, ito, free end not ito, or overhang. Pagka free end, pag nag-apply kayo ng load, pagka nag-drawing kayo ng elastic curve, meron yang rotation or slope at meron yang deflection. So magdi-deflect at mag-rotate pagka free end. Okay? So ito yung mga boundary conditions natin. So dapat alam nyo ito to simplify yung ating equation. Diba? So pagka at x is equal to 0, pagka dito sa example natin, pagka sinabing at x is equal to 0, alam nyo na at x is equal to 0, yung may support tayo na hinge. So alam nyo na merong tong slope, pero yung deflection niya, 0. So magagamit nyo yung equation ng deflection. Diba? To solve for yung constant natin pagka nagka-integrate tayo. Ganun yun. Okay? So dapat alam natin yung boundary conditions. So ito yung boundary conditions natin for slope and deflection. Okay? So meron tayong procedures in solving double integration. Okay? This is raised to... Okay, mag-take down notes pala kayo dito sa example. Okay, ibibigay ko yung notes, yung example, mag-take down notes kayo. Okay, so meron tayong procedure in solving for the equation using double integration method. So yung una, we have to determine yung reaction natin. Okay? Yun yung una. Palagi naman, yung unang ginagawa natin is to determine the reaction. Okay? So, we have here an example. So, let's take this example. Yung una, to solve for our reaction. Okay? So after solving for the reaction, you need to sketch your elastic curve. This is important to know yung mga boundary conditions natin. Okay? So you have to sketch yung elastic curve natin. Then use the method of section. So pagka alam niyo yung method of section, makukuha niyo yung MEI equation natin. Okay? So in using the method of section, pagka nag-section kayo, you have to make sure na makukuha nyo lahat ng load sa beam. Okay? So ito, simple example lang kasi ito na uniform load. So pagka meron kayong ganyan, meron kayong ganyan. So pagka ganyan yung load niyo, you have to make sure pagka nag-section kayo dito, kukunin lahat ng load. Okay? So start tayo sa left. Okay? So dito sa klase natin, Yung left support, yan yung pinaka-zero natin. Ito yung zero natin na x. Para uniform tayo, walang mag-start sa right. Okay? Start tayo sa left. Ito yung zero natin. So pagka nag-section natin, we have to make sure na makukuha natin lahat ng load. So pagka nag-section tayo, dito tayo diyan tayo mag-section. Okay? Mag-section tayo dito. Dito tayo magse-section kasi kuha lahat ng load. And then, kukunin natin yung MEI diagram. So, dapat alam nyo ang pagkuha ng moment. Diba? Method of section na discuss nyo yan sa statics of rigid bodies. I think statics of rigid bodies. Okay? So, pagka nag-section kayo, kukunin nyo yung MEI equation natin. Okay? So, pagka nakuha na natin yung MEI equation natin, doon na kayo mag-i-integrate. Okay? So, integrate this expression of M twice. Okay? So, twice to obtain yung expression ng deflection. Twice, expression ng deflection. Yung magiging, tawag nito, resulting na function. Pagka nagka-integrate kayo ng dalawang beses, yung makukuha ninyo, equation for deflection. Okay? Then, you also have to evaluate yung constant. Diba? Pagka nag-i-integrate kayo, pag maalala nyo pa, pag nag-i-integrate kayo, diba, meron kayong, for the first integration, meron kayong C1 kasi nagdadagdag kayo ng X. So, may plus C1. That is the constant. Then, pagka nag-integrate kayo ulit, diba, C1X plus constant. Dalawang constant. So, meron kayong C1, constant 1, and C2, constant 2. Diba? Pag nag-i-integrate tayo, meron tayong constant. Okay? So, makukuha natin yung C1 and C2, yung constant natin, pagka alam natin yung boundary condition. So, masosolve natin yung value ng constant pagka alam natin yung boundary condition. Diba? So, pag in-apply natin yung boundary condition, makukuha na natin yung value ng constant. Okay? Clear yun, ha? So, pagka dito, sa example natin, at x is equal to 0. Ang deflection natin dyan 0 kasi naka-hinge. At x is equal to 8. Ang deflection natin dyan 0 kasi meron tayong support na roller. Okay? So after evaluating yung values ng constant natin, we have to substitute the values in our expression to determine our slope and deflection. Okay? So yan yung steps for solving equations, slope and deflection using double integration method. Okay, so kindly unmute. Kindly unmute your okay. So ganyan. So let's take an example. Okay. So let's take an example here. So naririnig nyo ba pa rin ba ako?
Yes, ma'am.
Okay. So as simply supported prismatic beam. Pag sinabi nating prismatic beam, yung I niyan, pare-parehas hanggang sa dulo to dulo. Pagka sinabi nating prismatic beam, pare-parehas yung I, value ng I. So pagka non-prismatic, yung una, pag 2 meter, 2I yan, and the rest, I, or yung pangatlo, 3I, yan, non-prismatic beam. So, hindi pare-parehas yung eye natin. Okay? So, simply supported prismatic beam, pare-parehas yung eye. So, yung value natin is 240 raised to 10 times 10 raised to 6 in mm to the 4. Okay? So, a simply supported prismatic beam shown here is 8 meter in length. So, yung length natin is 8 meter and carries a uniform load of 30 kilonewton meter. So, meron tayong 30 kilonewton meter. Using E is equal to 200 GPa, tapos yung I natin is 240 raised to 6 mm to the 4th. We have to calculate the slope and deflection at 2 meter from the left support. Okay? So, ang isosolve natin dito is slope and deflection at 2 meter from the left support. Okay? So, sabi natin kanina, yung unang gagawin natin is we have to determine the reaction. So, kindly solve for the reaction if this is A, this is B. So, pakisolve nga yung reaction sa A at sa B.
Ma'am, 15-15.
Ilan ito?
Ma'am, 15-15.
15
Ma'am,
kilonewton.
yes. Ma'am, yes.
15 din ito. So,
Ma'am,
kindly
yes.
check. 30 times 8 divided by 4. Divide by 8. 30 times 8 divided by 2. 15. 30 times 8 times 4 divided by 8.
Ma'am, 30.
So, pakisolve ito. Wala akong calculator.
30, ma'am.
30?
Yes, ma'am.
So, yung $30 times 8. Are you sure? Hindi naman.
120.
120. Diba? In kilonewton. Okay. So, be very careful sa pag-solve ng reaction kasi pag mali na yung reaction ninyo, mali na lahat yung susunod. Hindi ko na ipapakita ito kasi syempre na dapat expert na kayo sa pagkuha ng reaction. So, uniform load, 30 times 8 times 4 divided by 8. 120. Pagka nag-summation forces upward na kayo, pagka nakuha nyo na yung isang reaction, makukuha nyo din yung isang reaction which is 120. Okay? So, be very careful sa pag-solve ng reaction. Okay? So, yung reaction natin is 120 sa A, 120 sa B. Okay? So, after solving yung reaction, i-drawing na natin yung elastic curve. So, dito sa A, 0 yung deflection, pati dito sa B, 0 yung deflection. Pero meron tayong slope dyan. Meron tayong rotation. So, pag ganyan yung magiging. Yan. Okay? Ganyan yung magiging elastic curve natin. Kasi merong yung load, so bababa yung elastic curve natin. 0 deflection dito sa A, 0 deflection dito sa may B. Okay? Then after sketching, we have to use the method of section. So, isa-section natin yung ating beam to get the bending moment equation para makuha natin yung moment equation natin. So, ito, uniform load dito. So, madali lang. So, pagka nag-section ka dito, so let's say ito, nag-section ka dyan, from the left, denoted that as X kasi hindi natin alam kung anong distance basta nag-section ka dyan. Hindi mo alam kung saang distance ka nag-section. So, X, denote natin yan as X. Okay? So we have to determine the equation of bending moment for the beam by passing a section at a distance x from any support. Pero tayo dito sa klase natin, pagka nag-start tayo sa left, ang left natin 0. Okay? So pagka nag-start kayo sa right, ang right ninyo is, ito yung magiging 0 ninyo. Okay? Ganun na. Kasi there are some instances na mas madaling mag-section pag galing sa right, mas madaling mag-section pag galing sa left. Okay? So pagka dito kayo sa left, na unang nag-section, ang 0 nyo dito sa left. Okay? So pagka sa right kayo nag-section, ito yung magiging 0 ninyo. Okay? So yung A yung magiging 8 ninyo. Ganun na. So kung saan kayo nag-start, nag-section, yun yung magiging 0 ninyo. Okay? So dito sa example, dito ako nag-section from A, so ang 0 ko andito. Okay? So ma-solve na natin yung ating moment equation. Okay? Paano i-solve yung moment equation? Paano kunin yung moment equation pag nag-section tayo? So pagka nag-section kayo, yan. Ganyan yung magiging lalabas, di ba? And then meron tayong tawag nito, reaction dito. Tapos ito yung x natin. So pagka nag-method of section kayo, di ba magmo-moment kayo dito sa section? Di ba? Kunin natin yung moment yan. So pag kunin natin yung moment yan, yan yung magiging moment equation natin. Magmo-moment kayo dito. Okay? So paano kayo mag-moment? Okay? So 120, magmo-moment tayo dito sa section. 120 times x minus 30 times x. This is a uniform load. Uniform load ito. So times x times yung centroid. Distance of centroid from your moment section. So x over 2. Yan. X over 2. So yung magiging moment equation na natin dito, M is equal to, pagka nag-moment kayo dyan, 120 times X, that is for the reaction, minus 30 times X over 2. That is the distance of the centroid from the section. Okay? 120x minus 30x, x over 2. So, MEI, divide natin yung MEI natin, yung flexural rigidity. Kasi ito yung kailangan natin, yung MEI equation. Okay? So, MEI is equal to 120x minus 30x over 2. Okay? Mag-close mamaya itong Zoom. Mag-zoom ako ulit kasi limited lang ito ng 40 minutes. Okay? So, hintayin nyo lang. Mag-zoom ako ulit. Mag-close na ata ito.
Ma'am, upgraded to unlimited ko na. Ay, to ko ako.
Ma'am, nakamute ka.
Hello.
Nakamute. Okay, sorry, nakamute ako. Hintayin na lang natin na mag-close ito. Tapos pagka nag-close, i-open ko na lang ulit. Okay, so check-in na lang kayo ulit dito. So, ituloy muna natin itong solution natin. Okay? So, ang d squared y over dx squared, pwedeng i-rewrite natin yan as y to second. Okay? Tapos yung dy over dx is equal to y prime. Okay? So, ito yung magiging slope natin. Okay? Diba ito yung first equation natin. Ganyan. Pagka in-integrate natin yan, syempre, magiging y prime na lang. So, yun yung magiging slope natin. Okay? So, itong equation na ito yung d squared y over dx squared. Pagka in-integrate natin yan, magiging slope. Pagka in-integrate ulit natin yan, yung dy over dx magiging y na lang. Diba? Pag in-integrate natin yan, ang makukuha natin dito is yung deflection. Okay? So, start natin. Integrate natin. Paki-integrate nyo nga ito. Yung equation natin. So, d squared y over dx squared. So, 120x minus, this is 30, 15x squared. 15x squared. So, paki-integrate nga ito, dy over dx. Ano yung magiging dy over dx natin?
Ma'am, 120x over x squared over 2 minus 15x cubed over 3 plus c1. Over 3, ma'am. Plus
Okay.
c1.
Okay. So, I hope na alam nyo pa rin kung paano mag-integrate ng power rule ata ito. Diba? Nagdadagdag tayo ng x. Okay? So, 120x, dagdag ka ng isang x squared. Kung anong dinagdag mo dito, over denominator. So, minus 15x squared kasi yan, kaya magiging x to the third times 3. So, pagka meron kayong value dito, for example, meron kayong 1/2 dito, yung dinagdag ninyo, ita-times nyo din dyan sa may constant ninyo. Okay? So, I hope na maalala nyo pa kung paano mag-integrate ng power rule ate. Thus, yung constant. So, yan yung magiging unang integration natin. So, etong equation na ito, yan na yung magiging slope equation natin. Okay? So, yan na yung magiging slope equation natin. Pagka in-integrate nyo ulit yan, dy dx, pag in-integrate nyo yan, magiging y is equal to, ano ito? Integrate nyo nga ulit ito, 120x cube
Over 6, ma'am.
x cube. Ilan ito? 15. So, pag-integrate na ito, 15x to the 4th over, ilan ito? 4 times 3. This is 12, diba? Plus C1 x plus C2. So, meron na tayong constant na C2. Okay? So, ito na yung magiging deflection equation ninyo. Okay? So, yan yung magiging third step na ay fourth step kasi nag-integral na tayo, makukuha natin yung expression. Okay? So, next step is to evaluate yung value ng constant. Yung C1 and C2 kasi hindi natin masosolve yung slope and deflection natin hanggat wala yung value natin ng C1 and C2. Diba? So, paano natin isosolve yung value ng C1 and C2? Okay? Diyan na papasok yung ating boundary condition. Diba? Pagkasabi natin, pagka hinge and roller, yung deflection niya, 0. Okay? So, gagamitin natin yung boundary condition na yun to solve for the constant C1 and C2. Okay? So, sabi natin, ang deflection natin sa A at deflection natin sa B is 0. Kasi both support yan. So, yun yung gagamitin natin to solve for the value of C1 and C2. Okay? So, at support, at A and at B, walang deflection. So, Y is equal to 0. So, ano yung gagamitin natin dito? Yung equation ng deflection. Kasi pag sinubstitute natin yan, 0 yan, masosolve natin yung value ng C2. Diba? At support, yung deflection niya is 0. This is the deflection. At support din, at support A, ang x natin is 0. So, dito tayo.
Ma'am, naka-mute ka.
So, paki-substitute yung value ng x and y natin sa ating deflection equation. Okay? X is equal to 0 kasi yung support natin nasa 0. Okay? At A. Support is x is equal to 0, y is equal to 0. Substitute nyo yung value ng x 0 dito, y 0 dito. Masosolve natin yung value ng C2. So, paki-substitute yan. Do not forget pala yung EI natin dito. Ano yung magiging value natin ng C2? So 120, 0 cube over 3 minus 15, 0 to the 4th over 12 plus C1 times 0 plus C2. Ano yung magiging C2 natin dito? 0.
0.
Okay, 0. Kasi 0 lahat ng x, 0 lahat ng y. So, yan na yung magiging value ng C2 natin. Okay? So, paano natin kukunin yung value ng C1? Okay? So, gamitin natin yung isang support. So, at support sa B, at support B, yung deflection natin, 0 pa rin. Pero ano yung value ng x natin? Meron tayong value ng x kasi nag-start tayo dito gumawa ng equation. So anong value natin ng x? 8 meter. Okay? So pagka sinubstitute nyo ito sa ating deflection equation pa rin kasi deflection yung ginamit natin na y is equal to 0. Okay. So pagka sinubstitute ninyo ito, y is equal to 0, x is equal to 8. Masosolve natin yung value ng C1. Kasi meron na tayong value ng C2, di ba? 0. So, isubstitute nyo lahat yan, masosolve natin yung value ng C1. Okay, so 0 is equal to 120x to the third power over 6. Sorry, this is 6. 6 minus 15 8 to the fourth over 12 plus C1 times 8 plus 0. So ano yung magiging value natin ng C1? Paki-solve ito. Ano yung magiging value natin ng C1?
$640, ma'am.
Ilan?
$640, ma'am.
Okay, 640.
40.
Ma'am, 5120.
So, ano yung tamang sagot? O majority? Pakikan? 640 or anong isa?
5120, ma'am.
5120. Wait lang, kuha lang ako ng calculator.
Divide the what's 5148.
X41.
So, tama ba yung ano ang sagot natin dito?
Ma'am, 640.
641, ma'am.
8 cube
640.
12 plus alpha x is 8. So we will be getting negative 640. Negative 640 naman yung lumabas sa calculator ko. Tingnan nyo nga.
Yes, ma'am, negative.
Okay. Negative 640. Okay. So meron na tayong value for C2. Meron na tayong value for C1. Okay. We can now solve yung hinahanap natin na slope at deflection. Yung slope at deflection at 2 meter from the left support. So pagkat sinabing 2 meter from the left support, ang left support natin at A. So ano yung kinukuha natin? Slope at deflection at x is equal to 2. Okay? Yun yung kinukuha nating deflection. At 2 meters, yung magiging x natin is 2 meter. Okay? So, solving for the slope, pagka sinolve yung slope, ang kukunin nating equation, yung equation dito, which is 120x squared. Okay? So, ayan yung gagamitin natin to solve for the slope. So, 120x squared over 6 minus 15x to the fourth over 3 pala. 15x cube 3 plus C1. 15x cube over 3 plus C1. Okay? So, alam na natin yung value ng C1 natin, which is negative 640. Okay? So, bakit x is equal to 2? Kasi yan yung hinahanap natin sa problem. Sabi ng problem, we have to calculate the slope and deflection at 2 meter from the left support. So, since sa left support din tayo nag-start nung pagkuha ng moment equation, 2 meter yung magiging x natin. Okay? So, to solve for the slope at 2 meter from the left support, we have to substitute 2 meter dito sa ating equation. Okay? So, paki-substitute nyo yung 2 meter sa ating equation. 22 squared over 6.
Ma'am,
Over 2. Sorry. Over 2.
Data ka.
Okay, so over 2. Over 2 pala, sorry. Over 2. So, squared over 2 minus 15x2 cube over 3/3 ba yun? 120x plus C1. Plus, yung C1 natin, negative 640. So, negative 640. Okay? So, ano yung magiging slope natin dito?
444.
Negative 440, ma'am.
Okay, so negative 440. Ano yung magiging unit natin pagka slope? Ano yung magiging unit natin dito pagka slope? Ano yung magiging unit natin?
Kilometer.
So,
Kilometer.
eto, pagka moment equation, ang unit natin dyan, kilonewton meter. Di ba? Nagdagdag tayo ng isang x, so ang magiging slope natin is kilonewton meter squared. Okay? Remember, ang unit ng moment is kilonewton meter sa equation. Tapos nagdagdag tayo ng isang x. Pag nag-integrate tayo, nagdagdag tayo ng isang unit ng x, which is meter. Okay? So, ito yung magiging slope natin. So, since given naman yung EI natin, pagka hindi given yung EI natin, ilagay nyo lang dyan, yung slope natin is negative 440 kilonewton meter squared over EI. Okay? However, given yung EI natin, ano yung EI natin? 200 GPa, tapos yung I natin is 240 raised to 6. So, substitute nyo lang yan. Okay? So, we have negative 440. This is in kilonewton meter squared. So, dapat ang unit din natin dito sa baba is in kilonewton meter squared. Di ba? Ang unit din natin dito is kilonewton meter squared. Ano yung unit ng GPa? Ano yung unit ito? Di ba yung GPa is 200 raised to 6 kilonewton meter squared. Di ba? Or 200 raised to 9 kilonewton Newton mm squared. Ba? So, ang GPa in kilonewton meter squared, that is equal to 200 raised to 6. Okay? So, yung mm to the fourth natin, gagawin din natin yan na in mm raised to 240. Raised to fourth, gagawin din natin yan na raised to fourth, meter raised to fourth. Para consistent na meter, magka-cancel yung meter dito, tapos magiging meter. Kilonewton meter squared yung matitira. Okay? So yung I natin, gagawin nating meter to the fourth, tapos yung E natin, gagawin nating kilonewton meter squared. Okay? So yung E natin, 200 GPa, that is 200 raised to 6 in kilonewton meter squared. Okay? So times yung I natin, 240. That is 240 times 10 raised to negative 6. So pagka sinolve nyo kasi yan, 240 raised to 6 mm to the fourth, pagka ginawa nyo meter to the fourth, magiging raised to negative 6. So 240 raised to negative 6 in meter to the fourth power. So pagka nag-cancel yan, nag-cancel ito, magiging meter squared. Ang lalabas dyan, kilonewton meter squared. Okay? So magka-cancel na yung unit natin dito. So ang magiging slope natin, wala tayong wala tayong unit. Ang unit natin dyan is in radian since this is a rotation. Walang unit na matitira, di ba? In radian. So, ilan yung value natin for the slope? Paki-solve ito. This is negative 9.17. 167. 3 units tayo. 167 times 10 raised to
Negative 3.
3. Okay. So, yan na yung magiging slope natin. Okay? So, ano yung meaning ng negative? So, negative means yung slope natin is downward. Ganyan yung slope natin. Clockwise from the beam. Downward clockwise from the beam. Negative. Okay? So, for the deflection, at 2x is equal to 2 meter. So, pagka sinusolve ninyo deflection, ang gagamitin natin yun, equation is yung equation ng deflection, which is EI over Y, 120x cubed over 6 minus 15x raised to 4 over 12 plus C1x plus C2. Okay? So, substitute lang natin yung value ng ating x, 2 meter. So, 120 2 cubed over 6 minus 15 2 raised to 4 over 12 plus C1 natin is negative 640 times 2 plus 0. So, ano yung magiging value natin dito? So, paki-solve na ito. Anong magiging value natin dyan?
Negative 140 ma'am.
So, we have negative 140. So, anong unit natin dito? Naka-kilonewton tayo, naka-meter tayo. So, kilonewton meter to the third power. Okay? So, dapat consistent yung unit natin dito. So, pag kilonewton meter to the cube, to kilonewton meter squared dito. So, parehas dito, ito yung magiging sa baba natin. Okay? So, pagka nag-cancel yan, may matitirang 1 meter sa taas. So, ang magiging unit natin dito, pagka sinolve natin ito, is meter. Okay? Meter yung lalabas kasi naka-meter din yung ating problem. Okay? So, ano yung magiging value natin for our deflection? Anong magiging unit natin dyan?
0.036 kilonewton meter.
Negative 0.0236
0.03.
para mas tama. 02375 yung nasa calculator ko. Tama? In meter.
Yes, ma'am.
Okay. So, ito yung magiging deflection natin. So, y is equal to negative 0.02375 meter. So, negative means yung deflection natin is in downward direction. Itong negative na ito. Okay? So, yan yung solution natin for problem number 1 using yung moment double integration pala. Okay? So, question. Wala pa? Okay, let's have another example. So, dito, balikan ninyo yung method of section ninyo. Okay? Kasi pag mali na yung moment equation ninyo, syempre, yung susunod na solution ninyo, mali na din. Di ba? So, balikan ninyo yung method of section. Okay, so naririnig nyo pa ba ako?
Yes, ma'am.
Okay, so we have here another example. So dito, we have to determine the maximum deflection. Okay? So for the problem number 2, we have to determine the maximum deflection using double integration method. Okay? So unang gagawin to solve for the reaction. So kindly solve for the reaction of this beam. Hindi ko na isusulat kung paano mag-solve ng deflection. Kindly solve for the deflection. O, sige, moment tayo ng B equal to 0. Assume natin positive. So, pagka ito yung A, ito yung B. Okay, RA minus 1/2 of 30 times 8 times 8 over 3. So, ano yung RA natin? And pagka meron na tayong RA, masosolve na natin yung RB. Okay? So, kindly solve for RA muna. Ano yung RA natin? Okay? Ano yung
Ma'am,
RA na? So, we have 40
Ma'am, 40.
kilonewton. So, pagka sinubstitute nyo yung RA dito, pagka nag-summation forces vertical tayo, positive yung upward, ano yung magiging RB natin? Ano yung magiging RB natin dito? $40 plus. So we have 80 kilonewton. So yan yung magiging RB natin. So RA is 40 and we have RB 80. So paano yung magiging deflection na elastic curve natin dito? 0, 0 dito, tapos may load dyan, magde-deflect sa. So ganyan yung magiging elastic curve natin. Okay? So we have to create an equation of bending moment from the beam. Okay? So by passing a section at a distance x from any support, so kung saan yung mas madali sa inyo, from any support, from A or B. So mag-support tayo sa A dito para hindi na tayo mahirapan. Okay? So pagka nag-method of section tayo, magka-cut tayo dito kasi ang load lang naman natin is yung triangular uniform load. Okay? So pagka nag-pass tayo dyan, ito yung magiging x natin. Yan. Okay? So pagka nag-pass kayo dyan, ang lalabas, ganyan, di ba? This is x, ito yung 40. Okay? So pagka nag-moment ka dito, pag gumawa ka ng moment equation, gumawa ka ng moment equation, syempre hindi mo alam yung value dito kasi nag-pass ka dyan, di ba? Kasi ang given dito 30 at B. So wala ka pang value dito. So let's say ito yung magiging Q mo. So hahanapin mo muna yung value ng Q bago ka maggumawa ng moment equation. Kasi pagka nag-moment ka dyan, kailangan mo yung load na triangular dito sa taas, di ba? However, wala kang value dito. Kasi pagka nag-cut ka dyan, hindi mo alam yung value dito. Okay? So you need to first solve for the value of Q. So paano isolve yung value ng Q? Okay, so by similar triangle dito, yung Q is equal to X is equal to 30. Ito yung triangle natin, similar triangle. 30 is to X, 8. Okay? So ano yung magiging value ng Q natin? Q is equal to, in terms of X. So ano yung magiging Q natin? 30 over 8. Ilan to? 30 divide by 8. That is 3.75x. So yan yung magiging Q natin. So yan yung magiging Q natin. 3.75x. Okay? So pagka nag-moment tayo dito, pagka gumawa tayo ng moment equation, mag-moment tayo dito, uunahin natin yung reaction. Pag nag-moment tayo dito, 40 times x minus, this is a triangular, so 1/2 times q. Ano yung q natin? This is 3.75x. Diba? Q, yung value natin dito. Times yung, kasi di ba kukunin muna natin yung area. So 1/2 q times x times, kasi moment tayo, kunin natin yung centroid, yung distance ng centroid from the moment section. Yun yung magiging x over 3. Okay? Remember, moment tayo, area times the distance. So distance from the centroid ng uniform load. So kaya x over 3 yan. Kasi dito tayo nagmo-moment. Di ba? Tama? Okay? So yung magiging moment mo dito is 40x minus 1/2 times 3.75 of x times x over 3. Okay? So paki-simplify nga ito para mas madali yung pag-integrate natin later on. We have 40x minus, paki-simplify ito, 1/2 times 3.75 times 1/3. We have 0.625x raised to 3. So ito yung simplified na equation natin. Simplify muna natin para hindi tayo mahirapan later on sa pag-integrate. Okay? So ito na yung magiging moment equation natin. Okay? So pagka meron na tayo may moment equation, so d squared y over dx squared is equal to, over EI yan, so m over EI is equal to, ilan yun? 40x 625. So we have 40x minus 0.625x to the third. Okay? So integrate natin ito. So ito yung moment equation, over EI ito. Okay? So pagka in-integrate natin yan, ang integral niyan, dy over dx is equal to, so ilan yung integral nito? Paki-integrate ito, 40x squared over 2 minus 0.625x raised to 4 over 4. 4. Tama, 4. Plus C1. So, ito yung magiging slope equation natin. Okay? So, pagka in-integrate ulit nyo yan, ito yung magiging deflection equation natin, which is 40 x cubed over 6 minus 0.625x raised to 5 over 5 times 4, 20 plus C1x plus C2. So, ito na yung magiging deflection equation natin. Okay? So, we need to first solve the value of our constant C1 and C2 bago tayo ma-solve yung mga slope and deflection. Pero dito, ang kukunin lang natin dito is the maximum deflection. Okay? So, paano ito? Paano i-solve yung C1 and C2? Okay. So, gamitin natin yung boundary condition. So, ang boundary condition natin dito, at x is equal to 0, y is equal to 0. Tapos yung isa, at x is equal to 8, y is equal to 0. Masosolve natin yung ating boundary, constant C1 and C2. So, anong gagamitin nating equation? Yung equation ng deflection. Kasi yun nga yung na-determine natin na ang deflection natin at 0 at x is equal to 0. At ang deflection natin sa B, yung support B is 0 at x is equal to 8. Okay? So, at x is equal to 0, y is equal to 0, ano yung magiging value natin ng C2? Isosolve natin yung C2 kasi x0, y0, ang magiging value natin ng C2 is equal to 0. Okay? So pagka sinubstitute nyo ito dito sa equation ng deflection, 0 yung lalabas. Okay? At yung isang boundary condition natin at x is equal to 8, yung y natin is equal to 0. So ano yung magiging value ng C1 natin? So isubstitute natin dito sa deflection equation. So EI 0 is equal to 48 to the cube 6 minus 0.625 8 raised to 5 over 20 plus C1 8 plus 0. So ano yung magiging value ng C1? So paki-solve ito, value ng C1 natin dito. C1. Anong value natin dito?
Ma'am, 298.67.
So we have 200, negative 298.67. So yan yung magiging value ng C1. Okay? So meron na tayong C2, constant C2, meron na din tayong constant C1. Okay?
Ma'am, excuse me, ma'am.
Yes.
Ma'am, ang negative lahat ti answer dito.
Yes. Anya diay?
Ma'am, ang automatic na tanga negative lahat answer na dito.
Hindi.
Or
No. Kung anong na-solve ninyo, yun. Pagka negative ang lumabas, kunin niyo yung negative sign. Pagka positive, positive. Okay? Hindi
Positive,
lahat
ma'am.
negative. Positive ba ito? Okay.
Yes,
So,
ma'am.
Yes, ma'am.
so we have positive 298. Positive ba? Negative na yung lumalabas sa calculator ko?
Negative kasi ang exam.
Negative. Negative yung lumalabas sa calculator. Paki-check nyo ulit, negative 298.67 kasi yung lumalabas sa calculator ko.
Ma'am, tama lang negative.
Okay. So kung ano yung na-solve ninyo, kung ano yung lumabas sa calculator niyo, kunin nyo pa rin yung sign. Okay? So tsaka nyo na i-ano dito. Diba? I-carry din natin yung sign dito. So i-carry nyo lahat ng sign. Okay? So negative 298.67. Okay? So meron na tayong C2, meron na tayong C1. Okay? So, pwede na nating isolve. Ano yung sinusolve natin dito? We have to determine the maximum deflection. So, paano natin i-determine yung maximum deflection? So, sa example number 1 natin, given kasi na ang i-determine natin at 2 meters. So, alam natin yung x. Value ng x natin. So, dito, hindi natin alam kung saan yung x natin kasi hindi natin alam kung nasaan yung maximum deflection natin. Diba? So, kailangan muna nating isolve kung saan yung location ng deflection natin. Kasi yun yung magiging x natin. Okay? So sa example number 1 kasi natin, given na ang hanapin natin is at 2 meter from the left support. Dito, ang sinabi lang, we have to determine the maximum deflection. Ang problema, kahit na-solve natin yung constant natin, hindi natin alam kung nasaan yung maximum deflection natin. So, we have to solve first yung maximum deflection. So, paano i-solve yung maximum deflection natin? Okay? So, how to find the location of our maximum deflection? Okay? So, to find the location of the maximum deflection, we have to use the slope equation. Okay? So, gamitin natin itong slope equation. Bakit ito yung gagamitin nating slope equation? Okay? Bakit? This is because yung slope natin at maximum deflection is equal to 0. So pagka ganyan yung ano natin, andito yung maximum deflection natin. Diba? Okay? So yan, straight line yan. So andito yung maximum deflection natin. Meron tayong tangent line sa maximum deflection. Kaya ang slope natin dito is 0. At maximum deflection slope is equal to 0. Kaya gagamitin natin itong slope equation to find the location of our maximum deflection. Okay? So pag ginamit natin itong slope deflection, that is EI, 0 yung slope natin at maximum is equal to 40 x squared minus 0.625 x raised to 4 over 4 plus yung C1 natin, negative 298.67. Okay? So, masasolve natin yung value ng x natin. So, yung x natin dito, that will be now our location of maximum deflection. So, pakisolve nga yung x natin dyan. Pakisolve yung location.
1.57, ma'am.
Negative 10.523, ma'am.
Nasobra.
Ma'am, 4.15.
Okay, so what will be now our value of x? So remember, naka to the fourth yan. So maraming lalabas na value of x. Diba? Pero tignan nyo din, yung sino yung nagsabi ng negative 10 point something. Pagka tignan ninyo, yung distance natin is hanggang 8 lang. Diba? Diba? So hindi pwede yon.
Ma'am, 4.15.
So we have, yung isang value na lumabas is 4.15. This is in meter. So yan yung magiging x. Okay, so remember, pagka gumamit kasi kayo ng calculator, di ba? Ang lalabas dyan, may lalabas, negative 10 point something. Pagka inulit nyo, iba na naman yung lalabas. Di ba? Kasi naka-x to the fourth tayo. So, 4 ang x natin dyan. So, pagka ganyan, balikan ninyo yung algebra ninyo pagka nagsosolve kayo ng value of x. If you have x to the third, to the fourth, to the second, kasi ang lalabas na x dyan, pagka x to the second square, dalawa ang x natin dyan, dalawa ang value. Yung iba, hindi applicable. Kasi yung iba, error yung iba, naka-negative. Hindi pwede ang negative dito. Okay? Yung iba, lumalagpas. So, kailangan yung gumamit ng algebra to solve for the value of x here. However, pwede din sa calculator, pag sumamba yung calculator ninyo, mag-set lang kayo ng value ng x. Okay? Na malapit dito sa inyong length. Makukuha ninyo yung 4.15. Okay? So mag-set kayo ng value ng x na malapit dito sa length. Makukuha ninyo is 4.15. Okay? So i-review ninyo kung paano yung pagkuha ng x natin. You can actually use the calculator. Nag-set ako ng x, ang lumabas 14.15. Matagal lang siyang lalabas. Kailangan nyo lang maghintay. Kasi nagpo-process yan. Kasi x to the fourth, maraming value ng x yan. Kung x to the second, x to the third, di ba meron sa calculator nyo yan, yung pag-solve ng to the third. To the fourth ata, wala ata sa calculator ito, yung 991ES. Kasi hanggang third power, pwede nyo din gamitin yung equation sa calculator. Okay? So yung x natin dito for the maximum location is x is equal to 4.15. Okay? So ito na yung magiging location ng maximum deflection. Okay? So pagka sinabing determine the maximum deflection, ito yung kukunin nating x. Okay? So solving for the maximum deflection, syempre ang gagamitin natin yung equation natin dito sa deflection. Okay? So itong gagamitin nating equation sa deflection, then we have to substitute the value of x, which is 4.15. Okay? So paki-substitute yung 4.15 dito sa value sa equation ng deflection, makukuha natin yung deflection, maximum deflection. Ilan ito? Maximum deflection. Substitute nyo lang itong 4.15 dito sa my deflection equation. Twenty-4 point 15 raised to 3 over 6. 40. 40. Minus 0. 0.625, 4.15 raised to 5 over 20 plus. Ilan yung sagot natin dito? Okay, so ilan yung
Ma'am,
value natin? Negative
801.40.
801.459. Diba?
Or 5.
Paki-check kung tama yung ating values. Magkatugma yung values natin. Tama? This is in kilonewton meter cube over EI. So wala tayong value ng EI. So over EI. Ganyan lang yan. Ganyan lang yan. Pagka may value tayo ng EI, substitute nyo yung value ng EI para makuha nyo yung exact na naka-meter, naka-mm na deflection. Okay? So, negative means yung deflection natin is downward. So, ito na yung magiging maximum deflection natin sa ating sample problem number 2. Okay? So, do you have any question?
Ma'am, J man ko, J part TQ.
Bakit dito sa Q?
Ano na ito? Ano na nga clear, ma'am?
Di ba pagka nag-section kayo, for example dito, nag-start ako sa left, nag-section ako anywhere in between dito sa aking length. Kapag nag-section ako dyan, nag-cut ako, meron akong kinat na triangle. Diba? Nag-cut ako dyan. Kaso, yung kinat kong triangle, hindi ko alam yung value dito. Yung value niya dito. So, yan yung i-denote natin as Q. Diba? Pag nag-cut ka, hindi mo alam yung value niyan. Kasi ang value na 30 kilonewton meter is sa may B. Sa may support B yung 30. So pagka nag-cut ka, hindi mo alam yung value ng Q. So paano isolve yung Q? By similar triangle. So pagka nag-similar triangle yan, pag ito yung kinat mo, yan, ito yung kinat mo. Diba? Pag nag-cut ka dyan, hindi mo din alam yung distance, kaya X. Okay? So by similar triangle, Q, ito yung Q natin, Q is to X, equal siya sa 30, ito yung isang triangle natin kasi similar triangle, 30 is to 8. So we have 30 is to 8. Okay? So yung Q, ang isosolve mo sa Q is in terms of X. Kasi hindi mo pa nga alam yung value ng x. Okay? So 30 divided by 8 is 3.75. In terms of x, yung q, kaya 3.75x. Okay? So yan yung magiging value ng q natin. Nasagot na ba yung tanong mo, Miss?
Yes, ma'am. Yes, ma'am. Okay yun.
Okay. So any question? Wala na? I hope you have nag-take down notes kayo dito sa ating example. Okay, so next meeting, Wednesday. So we have to wait for further announcements sa Wednesday kasi pagka foundation day, baka suspended yung class. Okay, so Wednesday. Pero pagka hindi suspended yung class, mag-activity kayo dito sa double integration. Okay?
Ma'am, mabalag pasyente more nga sample to inti Google Class.
Okay, okay. I will just scan some example for double integration. So pagka may libro kayo, yung reference ko is yung libro ni Kasimali. You have book, maraming example doon. Pagka wala, meron tayong online library. Alam ko merong Aslam Kasimali sa library. Okay, so I will just scan some problem using double integration. Okay, any question?
Ma'am, i-upload mo ba dito yung record video?
Yes, I will upload it later. Kwan siguro kasi mahirap mag-upload ng video sa, baka ma-upload doon dito eh. Ito yung na-record nga video, baka i-upload ko. So kindly open all your cameras. Okay, so yung mga hindi pa nag-attendance doon sa form, paki-fill out na lang, nasa chat box natin. Okay. So kindly open all your cameras. 26. Okay. Present ata kayo lahat. So 1, 2. Okay, so lahat ba nag-attendance sa form?
Ma'am, ano na di?
Nasa chat box.
One month, ma'am.
ma'am.
Okay, so i-copy ko na lang. Tapos dagijahan pa nga nag-attendance, mag-attendance kayo. Since I will be checking strictly your attendance. Okay, so dagijay nag-attendance, pwede nang mag-leave. Yung mga hindi, eto. Okay, meron na yung link sa chat box. Pakitignan na lang. Okay, so before you leave, mag-attendance muna dito sa may link. So after yung mag-attendance, pwede na kayong mag-leave sa Zoom natin.
Although mawat iti GMT sample kat ko, because langay nga talo iti hinge na kakasiyay. Ni Di ba sample style lang kat duwa nga support?
Okay, okay.